Hello, this is Mr. Collier, and today we're doing arithmetic sequences and series applications, and we're going to be specifically looking at some simple interest problems in a second as well. Okay, so let's take a look at a couple of examples first. The sale of smartphones is growing every year. The first year, the number is 25 million. Fourth year, it's 35,800,000. Okay, so this is first year and fourth year. So from first year to fourth year, we're adding the common difference each time. Okay, so that means that 25 million plus 3D has to be equal to 35,800,000. Okay, so you can just solve this equation to get D. So 3D equals 35,800,000 minus 25 million is 10,800,000. And then we divide by 3 and we get D equals 3,600,000. So that's the number of cell phones increasing each year. Find the predicted number of smartphones at the end of the ninth year. Well, that's U9 using our arithmetic sequence formula from our formula booklet. So let's take a look at the formula booklet. Yeah, we use this formula here to find the ninth term. So U1 plus n minus 1 times D is 25 million. Plus 9 minus 1 times D in this case is 3,600,000. Okay, if we do that, we get 53,800,000. Now let's look at the next one. We've got this person's going to collect watermelons 2 meters away each time. There's 100 watermelons, 2 meters away. So we have to get what distance must the boy travel starting from the truck to gather them up one at a time and return. Okay, so you might think the common difference is 2, but he has to go to the watermelon and then come back. So what you're really doing is the first trip takes 4 meters, and the second trip takes 8 meters, and then it's 12 meters, and so on. So the common difference is actually 4. Alright, so for this, we're going to use the formula for the sum of an arithmetic sequence. Okay, this one right here. So the sum, I guess we can call it sum 100, equals 100 over 2 times 2 times 4 plus 100 minus 1 times 4. And if you put that into your calculator, you get 20,200 meters. So that's over 20 kilometers, really. Okay, next we're going to look at simple interest. If you borrow money from a bank, you have to pay interest. So simple interest is just you get the same percentage each year. Okay, and you get the same amount every year. So it is an arithmetic sequence. Okay, so let's take a look at an example. Deposit 5,000 in a savings bond for 6 years at a rate of 3%. How much interest is earned each year? That's just 3%. Oops, 3% of 5,000, which is $150. Each year, that amount doesn't go up based on the principal. How much interest earned in total? Well, that's just simply 6 times 150, which is $900. And what makes this arithmetic is there's a constant increase of 150. Okay, we can generate a rule for calculating the amount, given the initial amount, the rate, and the number of years. So the amount of interest earned is C times R times N, like we just did here. We did 5,000 times 0.03 times number of years, 6. So that's a formula for calculating compound interest. Okay, so let's look at another couple of examples. Okay, 1200 invested simple interest, 5%. How much do they earn if they invest for 4 years, 6 months? Well, that's 1200 times 0.05 and times 4.5 years, which is $270. What's the total value of the investment after 8 years? Well, it's a total value, not just the interest. So we have to take the initial amount and add the interest. The interest is 1200 times 0.05 times 8. So the total amount would be $1,680. Okay, and the next one, find the interest per annum if 2,000 grows to 2,800 in 4 years. So that's $800 over 4 years. So that's just 800 divided by 4, which equals $200 is the interest per year. In part B, we can still use the formula I equals CRN, and we can put in 200 for the I. The initial amount is 2,000 times number of years. Well, actually, if we want to use the formula above, we have to put in 800 because that's how much total interest was earned in 4 years. Or you can use 200 and then n as 1. But let's do it this way. Okay, so this is $800 earned over 4 years, 4R, and this is 800 equals 8,000 R. So R equals 800 over 8,000, which is 0.1 or 10%.